Good morning, everyone. Thank you for joining us for the Automated Tire Pressure Sensor webinar. I'm Jess Helmlinger with the Kistler Group, and with me is Brian Taylor, Director of Sales and ITS with Intelligent Imaging Systems. Both Brian and I lead teams that have worked together to install automated tire pressure at initial sites with great success, and we're excited to share it today. A couple of housekeeping notes here before we get started and I hand over to Brian. This presentation is being recorded and we'll address questions at the end. By default, you guys are on mute. And then to ask questions, please type them into the Q&A section of the webinar, and we'll go ahead and answer those at the end as I mentioned. So with that, Brian, I'll hand over to you and look forward to hearing what you have to say.
Good morning. Thanks, Jeff. So we'll go to the next slide. And can everybody hear me properly? Probably can. So tire pressure sensing, it's not really a new technology. It's been around for quite a while. It evolved in the late 1980s with the introduction of piezoelectric sensor-based weigh and motion. And it's a little bit of a change from the traditional weigh and motion scales. In the late 1980s, some French technology came about with piezoelectric sensors. We ended up with a sensor, a weigh and motion sensor that was quite a bit smaller than the actual tire footprint. And in the processing of those signals, it became quite obvious that you could calculate the size of the tire footprint as well as the weight and divide the two together, divide one by the other, and you end up with pressure, the tire pressure. So it can estimate the tire pressure within a couple percent. And so these sensors have been around for quite a while. The technology was built into a large number of the commercially available piezoelectric weighing devices, and was originally a tool for the planning groups. Weigh and motion was actually developed for planning pavements, for estimating the amount of load that was on a pavement. So the functionality, to be honest, faded away. Nobody was really asking for it, and so people just stopped putting it in the systems. But in the last 5 or 6 years, there's been a real renewed interest from the truck enforcement community. And so the technology has been brought back. One of the main reasons in the truck enforcement area is that upwards of 25% of all the out of service in spot checks are tire related. So either flat tires, missing tires, underinflated tires, mismatched tires. So the technology was brought back. We reintroduced it into the Kistler data logger, and that's where we are today. So if you go to the next slide, please. Now, just some background. We're talking about using now the Kistler Lineas weigh and motion system, and some background on that. It's one of the most widely deployed weigh and motion systems in the world. It's been in North America and worldwide over 20 years. Jess and I were talking yesterday, and it's probably closer to 25, 26 years commercially installed. It's used in almost all U.S. states, several, if not most of the Canadian provinces, and 50 other countries around the world. So it is one of the most widely deployed weigh and motion technologies out there. And if you go to the next slide, we've introduced the ability to do tire pressure with the addition of a couple of sensors into a traditional weigh and motion quartz array. So the challenge within calculating tire pressure is that not all axles have two wheels on each side, or one wheel on each side. Some are dual wheel sets, some are single wheel sets. So in order to calculate the pressure, we need to know whether it's a single or a dual or a wide base tire. And we do that by adding two sensors tilted within the array. And those tilted sensors allow us to take a look at the tire footprint at an angle and determine whether or not it's a single, a dual, or a wide base tire. Once we know that, then it's a quick calculation and we have all the tire pressures. Then the system automatically compares the tire pressures to what they should be, looks for mismatches among that, and generates an alert within the WIM record to tell you whether or not there's a tire that's suspected of being underinflated. So, I mean, in the enforcement world, the traditional way of doing this was a kick test, walk up and kick the tires, but that doesn't really tell you if tires are significantly underinflated.
Brian, if I may just jump in, I'll confirm after doing a lot of testing at sites. We've actually even had officers do this test, come back and say, you know, hey, this tire is fine. And then when we put a gauge on it, it's right there close to 50% PSI, which is the out of service rating in most steads. So just wanted to echo that.
Okay, we can go to the next slide here. So this is what a typical array looks like. This is an installation in Mississippi where we have the traditional WIM motion sensors perpendicular to the pavement. In this case, it's a dual threshold or double threshold array for an ASTM type 3 accuracy. And we've added 2 tilted sensors. And like I said, the tilted sensors are to detect the dual, single, or wide base tire. And we'll go to the next slide. So the WIM motion system generates this as a flag on the WIM motion record. So from a WIM motion system, we get the number of axles, the weight of each axle, the spacing between the axles, and now the tire pressure sensor is alerting to a particular tire or number of tires that are underinflated or flat or it could be missing. And we take this information in IIS and we roll this into our smart roadside platform, our smart roadside software system. Smart Roadside is a roadside screening software system that can accumulate and display information to officers. And in this case, the screen you're seeing is from a site installed in Wisconsin. Now in Wisconsin, we have WIM motion, we have the flat tire, the tire pressure sensors, as well as an automated thermal inspection system. And the automated thermal inspection system is looking primarily for the lack of heat from brakes or bad brakes, but it also can identify tires that are overheating, which is an indication that they're underinflated or flat. And so in this case, you can see that we've integrated the display of potential flat tires right into the WIM motion record and subsequently match that to the corresponding tire on the automated thermal inspection system. So we have one complementing or augmenting the other, and rolling that into a single user interface really makes it intuitive for officers to take a quick look at the records, look at a truck and determine whether or not they want to inspect that truck. So the alerts are designed to be very graphical and audible. And as you can see in the raw data files here, this is raw data that you can drill down into. The tire pressure sensor from the WIM motion system matches what we've seen on and detected on the automated thermal system. In this case, we have a right tire that is suspected as being underinflated on the front of the lead tandem, the drive tandem. So we can go to the next slide. So as Jess mentioned, we've installed this now in 5 locations for 5 different states, and it's been operational for just over a year, 2 years, 1 or 2 years. And recently, during the road check in The road check, the Commercial Vehicle Safety Alliance's road check 2021, which was conducted in May, early May. It's a national blitz on inspecting trucks and looking for safety defects. The state of Maine had a brand new tire pressure sensor installed at the Kittery Way Station, as well as the automated thermal system, and we got some results from them showing the results from 2 years ago at road check versus the most recent. And what they noticed immediately was that they put significantly more trucks out of service for tire violations, almost 10 times the number of trucks for tire violations in this road check versus 2 years ago. And they attribute that pretty well all to the automated tire pressure sensor. The link on the right, we can make this available. There was a bit of a news splash where they had the media come out and they were showing off the system and talking specifically about their ability to detect the flat tires. And we'll go to the next slide. This is from Falfurrias, Texas. This is a new WIM Motion screening site, a smart roadside screening site in Texas. We were in the final stages of commissioning the entire system. The automated tire pressure sensor here detected a mismatch in tires. It comes out, it'll also look at mismatch. This is a dual tire set with an outside tire on the dual that's pretty well at the end of its life, and an inside tire that's brand new. And this caused a mismatch on the pressure and was detected and subsequently put out of service. And we'll go to the next slide. So in the world, we want to just bring up some new points and some of the things that are going on in the WIM Motion, in the area of WIM Motion. Besides, the addition of tire pressure sensing, we work very closely with Kistler to deploy WIM Motion systems and support them. And the one thing that we really want to stress to agencies is, these are sensor systems installed in pavements, and they do require ongoing service, maintenance, and monitoring in order to achieve the best performance and the longest life. And so one of the things we're working with agencies on is changing the way that these are traditionally purchased or the use of them is set up. So we're calling it WIM Motion Data as a Service. I'll talk a little bit more about that as we move forward, but it's where agencies effectively work with suppliers to put systems in and then basically buy the use of the system or rent the use of the system, not go through the standard acquisition and maintenance of them. And we'll go to the next slide. The other thing we wanted to bring up is some new advancements in WIM calibration. So IIS operates the DriveWise truck bypass program. This is a truck bypass program deployed across North America, currently in 46 states, 2 Canadian provinces. It uses the onboard electronic logging devices and the GPS and cellular communication to link these trucks in a connected truck network. And these trucks then, this technology is used to allow trucks to bypass weigh stations. One of the key requirements is that trucks are weighed as they bypass weigh stations. And so we have several hundred WIM Motion locations all tied together within DriveWise. We have someplace nearly 2 million trucks have the DriveWise software operational in them. And as a result, we can very accurately match truck location to WIM Motion location and the WIM Motion data. We can compare the WIM Motion data from multiple sites as a truck progresses through a particular network or a particular on a particular route. And we can then automatically in the background compare the performance of these weigh in motion sites to each other and to static events when those trucks enter weigh stations and are weighed statically. And the auto validation of the calibration takes place in almost real time. So we can tell whether weigh in motion systems are varying over time, over season, or if they just have a service problem. And again, there's a link here to a video that does much better justice than one slide on explaining how this works and the benefits of it. So I'd encourage you to take a look at this, after this presentation. And we'll go to the next slide. So the main advantage we see in putting these systems out there, there's a few key points to take away. First of all, that we're integrating the flat tire system into a smart roadside and making that very graphical for officers. One of the key points that I think makes this technology very attractive is that many of you currently are using quartz, Kistler weigh in motion systems. And those systems now can be easily retrofit by the addition of 2 sensors and an upgrade in software to provide flat tire detection as well as weigh in motion. And the two work hand in hand. The additional sensors in the array to do the flat tire, to help with the flat tire detection, improve the accuracy of the weigh in motion systems, and we get the flat tire detection out of that as well. As I mentioned, we have within Smart Roadside the ability to integrate to the DriveWise program to help with calibration, and we have other technologies to help match trucks from one location at a weigh station to another, for example, from a main line to a ramp to a static scale to assist in the validation of calibration, which is very important and quite costly. And we'll go to the next slide. And I mentioned this before. WIM as a service. A lot of agencies, I've been in this industry a long time, and I've seen these cycles of obsolescence where an agency will buy a number of weigh in motion systems and deploy them, and then work really hard to keep them running and within their budgets to keep the maintenance going on and to replace sensors as sensors fail and as pavements are upgraded. And but there are a lot of operational challenges to this from an agency's point of view, especially when budgets get tight and budgets are rolled back slightly. So we see it pretty regularly where agencies go for a period of years with minimal maintenance or no maintenance, and systems start to fail, and they go through these cycles where they then go and get some more capital funding to replace a lot of systems, and then we enter another 7 or 8 year cycle like that. So we're working with many agencies right now on WIM data and the use of these systems as a service, where IIS in partnership with Kistler will supply all the sensors and the equipment under a services contract, and effectively the agency, and this can be multiple departments within an agency, so enforcement or planning or economic development, they can all have access to the data as they need it in the formats they need it, and they pay for confirmed, accurate, and complete data sets. So if the systems don't work, they don't pay, but as long as everything is moving along, it's supplied as a service. And we'll go to the next. And with that, I'm going to open it up to questions and further discussion. And I think I'm going to turn it back to Jess. He's going to lead the Q&A.
Thank you, Brian. Well done. Good information. So yeah, got a few questions in here. Just as a reminder, if anybody that has questions, you can go ahead and enter those into the chat or Q&A section, and we'll go ahead and get those and ask those here. The first question I have here is, what is the accuracy of ATPS?
Okay, so there are some published specifications and whatnot going around, but typically the accuracy, and I'll qualify the numbers as I say them, but typically the accuracy is someplace better than 85%. We typically see we can see the like I say, a lot of states have specified 80% or better. What that really means is that if we stop 8 trucks, sorry, if we stop 10 trucks, I'm getting a large echo here, so it's distracting. If we stop 10 trucks, we'll put 8 out of service, is what that means. As with all these technologies, there is the ability to adjust thresholds, and and what that means is that what we want to be able to do is detect flat tires, detect underinflated tires without generating too many false positives or generating a lot of noise for officers where they're slightly underinflated and they're not an out of service. So we've been working very hard with agencies where we can set these thresholds based on the number of trucks that they're interested in looking at. But right now, all of the systems that we've been out there are better than 85% accurate in the ability to detect an out of service. So that like I said, that means if we alert 10 times, more than 8 of those will be an out of service. Go to the next one, Jess.
Yeah. Next question is, so the traffic monitoring section in my state has 20 to 30 quartz data collection sites that are being used. Could these also check tire pressure as well in one or more lanes?
And the answer is yes to that as well. Any way in motion site, any speed up to highway speed can be used. We can add the sensors, the tilted sensors, to any of those arrays and provide the data. In a case of a planning way in motion site or one that's used for data collection, the data would be stored as part of the WIM record. So all the alerts on tire pressure or flat tires would be associated with each individual weight record. We have agencies putting these out as part of virtual weigh stations. And again, it will be stored with the rest of the weight and image records from those. So a typical virtual weigh station will have cameras as well as the weigh in motion. And that could be overview, license plate reader, US DOT reading cameras. And it will just associate all of those alerts and all of those detected low tire or missing tire situations. It'll associate those all with that WIM record.
Great. Next question is, are you seeing a difference in detection of potential violations if the CMV is loaded or empty?
Definitely the accuracy on them is better. The confidence in the readings is better on loaded trucks versus empty, but it does work up to the 80% accuracy on empty as well. We haven't seen a degradation too much. It does give you better confidence when the axles are loaded or when the tires are at their when the actual axles are loaded. And the reality is the tire footprint changes in size when loads are applied. That's really the effect that we're seeing here. Like I say, the confidence is slightly better with with loaded axles, but it does work to the specification on empty axles.
Very good. Next question is about getting a copy of the presentation afterwards, and so yeah, we'll go ahead and make that available to people as a follow-up, people that are registered. So it will be available afterwards, I can say. The last question, or next question I have, there's a few questions about what the pricing is. And so I think what we would want to do there, we have everybody that's asked questions. And so we can follow up with anybody that needs pricing questions specifically as a follow-up here. And if you're interested in pricing options and things like that, Brian, I think we could, people could go ahead and ask that, and then we can specifically follow up with them because many times it's specific to installation sites, what they have existing.
Yeah, that's a really good point, Jess. Is that the as you saw in with not what we've discussed is that's the addition of 2 additional sensors to the array. You know, a significant piece of the price is installation. So new versus retrofit and whatnot are slightly different. So we would like to better understand so that we don't throw numbers out there that aren't real.
Very good. I think that's it on the questions here. We've got contact information for everybody here, both Brian and mine, as questions may come afterwards. So I think Brian, anything in closing?
No, just appreciate your time. I know it's you know, everybody's getting a little bit tired of webinars. We're looking forward to seeing you all in person and discuss these more as we start opening things up and attending more conferences coming in the future.
Right. Okay, and with that, we'll go ahead and close it out.
Okay, thanks again, everybody.
Bye, everybody.